Welcome and thank you for watching my videos. I really appreciate your time and attention. I hope you found the explanation of the trapping rainwater problem helpful and easy to follow. If you enjoyed the video, don't forget to like, subscribe and share it with others who might find it interesting. If you have any questions or comments, feel free to leave them below and I will be happy to engage with you. Let's dive into the content. Now let's get started. Today we will be solving the trapping rainwater problem, a classic challenge often encountered in programming interviews. We will be using the two-pointer technique to find an efficient solution. In this session, I will guide you through this problem and its solution. Let's begin. Let's start by understanding the problem statement. We are given an array of non-negative integers where each element represents the height of a block. The goal is to calculate how much water can be trapped between these blocks after it rains. The input consists of an array of integers where each element represents the height of a block. The width of each block is 1 unit. Our output is the total amount of water trapped between these blocks. Let's look at an example. Given the input array containing the elements is 3, 0, 1, 0, 4, 0, 2. We can calculate the total amount of water trapped. The output in this case would be 10 units of water. Here's another example. For the input array with elements 3, 0, 2, 0, 4, the total amount of water trapped would be 7 units. Consider the array with elements 1, 2, 3, 4. In this case, no water is trapped between the blocks, so the output is 0. Now that we understand the problem, let's explore the approach to solving it. Our goal is to calculate the total water trapped between the blocks. To do this efficiently, we will use the two-pointer technique. The two-pointer approach involves using two pointers, one from the left end of the array and other from the right end. We also maintain two variables, left max and right max, which track the maximum heights seen so far from the left and right ends respectively. We initialize two pointers, left starting at index 0 and right starting at the last index of the array. We also initialize left max and right max to be the first and last elements of the array respectively. In step 2, we compare the heights at the left and right pointers. If the height at the left pointer is less than the height at the right pointer, we process the left pointer and move it to the right. In step 3, if the height at the left pointer is greater than or equal to the height at the right pointer, we process the right pointer and move it to the left. We repeat this process until the left and right pointers meet. Now let's look at the code implementation. First, we define a function to calculate the total trapped water. We initialize the left and right pointers, left max, right max, and a variable to store the trapped water. As we enter the while loop, we check if the height at the left pointer is less than the height at the right pointer. If true, we check if the current height at the left pointer is greater than or equal to the left max. If not, we calculate the trapped water and update the total. Similarly, if the height at the right pointer is less than or equal to the height at the left pointer, we check the right pointer's height and calculate the trapped water accordingly. After processing, we move the right pointer towards the left. Let's walk through the code. We begin by initializing the left and right pointers and setting left max and right max to the first and last elements of the array. We also initialize the water trapped variable to store the result. As we move the pointers towards each other, we continue comparing the heights. The trapped water at each step is calculated by subtracting the current height from the maximum height encountered so far. Let's apply this approach to our first example. Here the array is 3, 0, 1, 0, 4, 0, 2. Initially we set left max to 3 and right max to 2. We start comparing the blocks from both ends and calculate the water trapped at each step. After processing the entire array, we find that the total trapped water is 10 units as shown in the detailed calculation. Now let's analyze the time complexity. Since we traverse the array once with 2 pointers, the time complexity is big of n, where n is the size of the array. As for the space complexity, the algorithm uses big of 1 extra space since we only store a few variables for left max, right max and water trapped. In conclusion, the two-pointer technique provides an efficient solution to the trapping rainwater problem with optimal time and space complexity. This approach is not only efficient but also easy to implement. Thank you for watching this video. I hope you found it helpful. Feel free to ask any questions or leave your comments below. Special thanks to everyone who made this content possible.